Everyone, so in this video we're going to look at function composition, and to define function composition a little bit more mathematically, the way it's typically described in a textbook is that you have function f, okay, and then folks use this circle symbol, and then you have a function g, okay, and then you have this parameter x over here, which is consumed by this function composition, and this gives you back this basically is equivalent of writing as f of g of x. Okay, so that's typically how you would see function composition defined in a math textbook. Okay, so just to kind of get some kind of an understanding, some kind of an intuition here, what it simply means is that look, if I have a function f, if I have one function f right there, and I've got a second function g, and again let me just use a slightly different color here. So let's use yellow for function f there. Okay, so I've got a function f which happens to be over there, and then I've got a function g. Okay, and the idea is that look, given these two functions and given some x there, some kind of a value x over there, okay, the way this is defined is that x first gets consumed by the function g. Okay, the function g is some function that consumes some kind of an input. The x gets directly consumed by g, and then whatever's the output that g gives you back, which is this piece, this entire piece over here is the output of g. Okay, whatever is the output of g then gets consumed as an input parameter to f. Okay, so what f is doing, f is saying, look, I also need some kind of an input because I'm a function. The input I'm going to get back is basically the output, is going to be the output of g of x. So whatever is the output of f then is this entire piece. This entire piece over here is the output of the function f. Okay, that's kind of in some sense, very informally, I've kind of outlined there what is function composition. But how does function composition relate to Haskell? I mean, what's the intuition here? Like, why have this? So you can think of, if you have many different kinds of functions, you now have the ability to glue them. You have the ability to merge them. You have the ability to combine different kinds of functions such that you can build a newer function, right? So you kind of reuse it. This is the idea of modularity in software design, where you're using the small bits and pieces of software and you're connecting them. You're connecting them to build some kind of a larger or more complex piece of software that at its very, very underlying root may just be a simple kind of putting these small bits and pieces together to form that larger piece of software. Okay, so let's do this. Let's kind of revisit this function composition. But now what I'm going to do is I'm going to say, uh, just exploring a little bit from a mathematical notation here. You can think about this f0g. You can think about this f0g. Okay, this piece over here as some kind of a new function, right? This piece in orange. This piece in orange is also some kind of a function. It's some kind of a function, right? Which at some point consumes this x and gives you back some output. It gives you back some output. Okay, so just to make it a little bit more clear, what I have here is, let's say, just to define this piece here, which is this zero there. Okay, this function composition operator, okay, has a certain type. It has a certain type in Haskell. It has a certain type in Haskell where it consumes two functions. It just takes in two functions. So let's just get some types here. Okay, so I'm going to say the first function is some function that goes from A to B. Okay, then I have a second function. I have a second function that goes from B to C. Okay, now this is the key here. What's really important here is that for the first function, okay, this function over here that goes from A to B, let's assume that this g that I have here is this function that goes from A to B. Okay, so let's just use colors again, and this g over here, again, let me put that in green. Whatever this function g is has a type that goes from A to B. Remember, it's just a function. It's a function. I'm using this arrow notation to signify it's a function. And these are my type signatures. And then I have a function f here, and I'm going to use for f, let's use blue. Okay, so I have this function f over here, okay, which has a type signature. It has a type signature that goes from B to C. Okay, now this is the key here. Whatever G consumes is this A there. Okay, some value of this type A. What G gives you back as an output is some value of this type B. But this is the key. The key is that whatever F consumes as an input must also be of the same type. that G gives you back as an output. And that's why I've got this B, the same B, the same B, the value that has whatever this value is, the type associated with that value is some type variable B here. Whatever this B is, it must be exactly the same as this B that is the type that G spits out. Now, once F consumes this B, it gives you back as an output some other value that has a type C there. Okay, so what is this function in orange then? This entire piece in orange there. That piece in orange, because it's also a function, it's also a function that consumes this entire piece in orange. This entire piece in orange is basically a function that consumes this x, which happens to have a type A. Okay, so I'm going to say this piece in orange is some function that consumes this parameter x of type A and spits out whatever is the output of this f of g of x. So what I really care about right now is the entire output of f there. The entire output of f is some value of type C. Okay, good. So this piece in orange is the output that you get back from the function composition operator. Or you could think about this piece in orange has this entire type there. Okay, and this piece in green is that type signature over there, and this piece in blue has this type signature. Okay, so let's just to complete this off. We can think about as or this function composition operator. It takes in a function right there. It takes in some kind of function in blue there. It takes in some kind of function in green there. So this piece in blue, okay, the first parameter consumed is this function in blue, which has that type signature. So let's just write that using that type signature. So I'm going to say this B to C. That's my first parameter. Okay, what does it require as a second parameter? Well, as a second parameter, it requires this G. Now, what's the type of G? The type of G is that piece there from A to B. Excuse me. So I'm going to put over here, I'm going to put in the function, which happens to be the second parameter that the function composition operator consumes. But what does it give you back as an output? What does this entire thing give you back as an output? Well, the entire thing that comes back from an output is this piece in orange, this entire piece in orange. So the function composition operator takes an F, takes an G, and spits out this entire piece in orange. And the entire piece in orange is also a function, so it gives you back as an output. It gives you back as an output, a function that goes from A to C. And that's the type signature. That's a type signature for the function composition operator. Now, in the next videos, we're going to kind of explore this a little bit more from an applied setting. How we're going to start using the function composition operator to build up different functions.